In this lesson, we are going to, again, focus a little bit more on that rigid transformations, okay, which are your rotations, reflections, and translations. So the first thing that you should have is a resource page that starts off looking like this, okay, rotations on a grid. So do you think it makes any difference if a rotation is clockwise, and clockwise means that it's going around the clock in that direction, or counterclockwise, which again is going the opposite direction? Okay, so what I want you to do is with your patty paper and your resource page, I want you to try to follow the directions and focus on the 180. Remember that you are going to put a little plus sign on that point of rotation. And so if you have to move it 180, I put a little dot here, and I have to move it in this direction, 180, this dot will move down here, okay? If it was 90 degrees, right, it would have moved just right here, 270, things like that. So, so again, the dot's just kind of there to help you. So go ahead, pause the video, and try to do these rotations on a grid. Okay, so if you're coming back from the paused video, right, I'm going to show you what is happening with our answers, and hopefully you guys can compare your answers with my answers. So these are what the new rotation should look like. So it's in a lighter black color. So this is 180 clockwise versus 180 counterclockwise. Did it matter for the 180 which direction we went in? And their answer is no. Direction didn't matter. So didn't matter. It ends up looking exactly the same. Okay? But if you look and compare C and D, notice that 90 degrees one way and 90 degrees the other way, the direction did matter. So direction does matter here when we talk about 90 degrees. Okay? Notice that 270 clockwise, this was the same as D. So this is the same as D, which means that 270 clockwise is the same thing as saying 90 degrees counterclockwise. So in this direction. Did 360 make a difference? No difference, right? Notice that this lovely N, again, no difference. And with the square, notice it also made no difference. Okay, so again, it's just some extra practice rotating it and really paying attention that 90 degrees, especially when it's not a perfect square, is going to make a huge difference. Okay, so let's continue. And on your graph paper provided, you are going to first draw the A point and the B point. Okay, so again, if you need to pause the video, please do so. So you're going to draw A, which is 4, 1, be right about there, and B, which is 2, 5, which is right about there. So put a little A and put a little B. Okay, so now you're going to use your tracing paper, okay, and you're going to rotate the 2 points 90 degrees counterclockwise. So again, it's going to go in that direction, and you're doing it over this point right here, which we're going to call O for the origin, okay, and you're going to make 2 new points, okay, and these 2 new points are going to be at -1, 4, which this becomes your A prime, and your B prime is -5, 2. So B prime. So again, I'll write that out. So A prime is -1, 4, and B prime is -5, 2. So I made 2 points. I want to connect my A to my O, my B to my O, and everything. So I'm going to draw some points, I'm going to draw some line segments, make that a little bit thicker, best of my ability, and draw another one. Okay, and one more. And I'm going to change my color too, so let's make that red. Thicker. And again, I'll change that to red and thicker. Okay, so we have made our points, we've traced it, we've connected them. What do we notice about the side, the side lengths? Okay, so do we notice anything about the B prime to O, and my B to O, right? So you might want to trace your OB. So yeah, actually go ahead and trace the line segment OB and put it directly on the line segment OB prime. What do you notice about those 2 points? And hopefully what you noticed is that they were the same. If you had drawn OA and OA prime as side lengths, right? These will also be equal, okay? So now what I want you to do is I want you to draw this entire angle right here. So I want you to trace this entire angle, okay? It doesn't matter if you trace this one. And I want you to see if this angle, right, matches up perfectly with this, okay? So does this green highlighted match up with the BOA highlighted region, okay? And what you should recognize is that our angles, the angle, this is our symbol for angle, AOB is going to be the same as our angle for A prime to O to B prime. They're the same. So again, I want you to recognize that for rigid transformations, what we mentioned earlier is that side lengths don't change and angles also don't change. Things are what's known as being preserved, okay? So in your notes or on your resource page, I would like you to copy this down. When measures do not change, right? Measures meaning angles or side lengths do not change. Mathematicians use the term preserved, as in I can say the angles measures are preserved. I don't know why I put double S. Angle measures are preserved. I didn't need another S right there. Or I can say the side length measures are preserved, meaning unchanged. So unchanged. That's essentially what's happening. Okay, and it's really important to kind of understand that rotation. Okay. Now, the other thing that I also want you to start thinking about, okay, and again, you might need to pause the video if you're not done copying this down, is this. Notice that when I rotated the points 90 degrees, notice that 4-1 switched positions. So notice that it went from quadrant 1 to quadrant 2, and so because quadrant 2 has a negative x, notice that, again, your x's and your y's switch. Okay, I want you to be thinking about that as we potentially are going to continue on with these lessons, right? Again, notice that 2, 5 switched, became 5, 2. But again, we're in the second quadrant. Second quadrant, your x's are negative while your y's are positive. This is something just to keep in the back of your mind. Okay, so let's take a look at another problem. So I want you to find this, this picture on your resource page. And the first thing I want you to do is I want you to draw 3 dashed line segments. If you don't draw them dashed, it's not a big deal. So basically I'm connecting my P to my P prime. So, so what I'm trying to do, I'm trying to go down and then over. That P to P prime is a little bit harder than Q to Q prime. Okay. R to R prime. Okay. Now, this is something interesting. Okay. I want to know what's the relationship between these 3 dashed lines. Okay. So if you look at R to R prime, notice I'm going down 1, 2. So I go down 2, and I'm going over 1, 2, 3, 4, 5. Oops, did I count correctly? 1, 2, 3, 4. I meant to say 4. So R to R prime, right? I go down 2 over 4. So I'm going to write that kind of as a slope, right? The slope of this line right here is -2, 4. Right? That's really the dashed line, I guess you were supposed to draw. I didn't really think about it that way. So dashed line, right? Dashed line. Those are our dashed lines. So R and R prime would be the slope of that line is -2 over 4. Notice for Q to Q prime, I also go down 2, and I also run 1, 2, 3, 4. So -2, 4. Okay? And then P to P prime, I'm going to go down, it looks like 1, right? So I'm at 3.5 to 2.5. So I'm going to go down 1, and it looks like I run 1, 2. So it looks like I go over 2. What do all 3 have in common about the dashed lines? These dashed lines all have the slope of -1/2, which means that these guys are all parallel lines. Right? Takes us back because their slopes are the same. Okay. Now, question number 2. It says, what do you notice about the line of reflection and the segment R to R prime? Okay. So let's look at the line of reflection. All right. So I'm going to change my color. So I'm going to start here, and I'm going to go here. So this line of reflection, I am going to the right 1 and up 2. So this line, L, the slope of this line is 2 over 1. Right? What do you notice about that? What you should have noticed is that R and the line L are perpendicular. Perpendicular slopes. Okay? So it's a way that we can kind of make sure that the distance between the two is the same. Okay? And if I put a point, a random point, right? Point N. So again, I'm going to change my color one more time. Let's make it orange. So I'm going to point N at the point of interception, right, of line L. Notice that if I go down 1 and over 2, I hit my line. If I go down 1 and over 2, I hit my line. So this happens to be my slope. So all I have to do is use my slope once, get to my line of reflection, use my slope again, get to my second line of reflection. Or sorry, second line, so to speak. So using this information, right, that I can see if 2 points are reflected over each other, right, I want to come across this problem. So Evan has graphed the point 5, 7, and he wants to reflect it over the line given. Y is equal to negative 2/5 x plus 6. So he predicts that the point will be 2, 2. So we want to confirm his answer without graphing, right? So we either want to confirm that it's true or it cannot be the same. Okay, so if we take what we just realized is that the slopes are perpendicular, right? The slopes of the lines are perpendicular. What we need to do is figure out what is the slope of these 2 points, all right? What's the slope of these 2 points? So what we are going to do is we are going to find the slope between 5, 7 and 2, 2. So remember your slope formula, change in y over change in x, which is y2 minus y1, x2 minus x1. So this will give me 7 minus 2, and then 5 minus 2. So 7 minus 2 is 5. 5 minus 2 gives me 3. Now, my slope was right here, negative 2/5. The x should not have been circled. Try that again. I'm just going to actually highlight it. Let's see if that's easier. There we go. So the question to ask ourselves is 2/5 and 5/3 perpendicular slopes? So perpendicular slopes. Is that really true? The answer is no, right? So basically, the reflected point is wrong, right? So it cannot be, so he cannot be correct. All right. Let's continue looking at a few more. So we've seen reflection, we've seen a little bit of rotation. So reflecting, right, we see that they're perpendicular slopes, and rotation, we see that the x's and the y's are changing. So let's look at this. So we want to describe the translation. So take a look at your picture, and how do you go from triangle A, B, C to the triangle A prime, B prime, C prime? So go ahead, pause that video right now and see what you have to do in order to get from one point to the other. Okay, so what you should have recognized is that you have to go down a certain amount of units and you'll have to go to the right. So you are actually going down 3 units and you are going to the right 7. So let's pretend I'm moving my A. So down 3, 1, 2, 3, and then I'm going to the right 7. 1, 2, 3, 4, 5, 6, 7. I get to my new point, right? Again, down 3, 1, 2, 3, and go 7. 1, 2, 3, 4, 5, 6, 7, and then one more. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So we've correctly identified our translation. So I want you to try your own translation on your graph paper. Okay, so let's plot these 3 points. Okay, and then you're going to use it as the same of the translation for ABC. So what did we say? We said we went down 3 and then to the right 7. If you want to try it on your own, please do. If not, follow along. And hopefully I made a graph large enough for this. We'll find out in just a second. So 4, 2 is right here. 1, 7 is right there. And G is at 2, 0, which is right there. Okay, G. All right, so then I'm going to connect my points together and make a lovely triangle and make it a little bit thicker so we can see it. There we go. Okay, so lovely triangle. Apparently I didn't make it that thick. Okay, so okay, so we have to draw our new points. So I'm going to go down 3, so I'll do the F first. So down 3, 1, 2, 3. So I'm here. And I'm going to go over 7. So 1, 2, 3, 4, 5, 6, 7. So my F prime, right, should be at the new point. Looks like it's 8, 4. Right, so that's how we can double check. I'm going to take the G, so I'm going to go down 3, so 1, 2, 3, and then over 7. So G prime, I should be at the point, looks like 9, negative 3. And then E prime, I'm going to go down 3, 1, 2, 3, and then over 7. I'm going to be off my grid. I'll be at the 11. So this will be E prime. So 11, negative 1. And again, we'll connect the points. This time I'll just draw them out. Draw it out like that. Okay. So we want to kind of ask, what do you notice about these line segments, so to speak? Okay, so do you notice anything? And what I'm talking about is, do you notice anything from FG? And do you notice anything about F prime, G prime? Do you notice anything about E to G and E prime, G prime? Okay, so just take a moment, kind of look at your picture and see if you notice anything. If you don't, no worries. But if you do, pause the video and kind of write it down. Okay, so if you didn't notice anything, not a big deal. But again, if we had patty paper, what we first should have, again, realized is that all of our line segments were congruent, were the same, aka they're called congruent. Just a fancy word that we use for the same. We'll use that word a lot more when we deal with geometry. Okay, but what else can we notice is our slopes, right? The slope of the line, m slope of FG, is actually the same thing as the m slope of F prime G prime. And how do I get to that? I'm going to go down 7 over 2. So this is negative 7 over 2. And this F prime to G prime is negative 7 over 2. So they're actually parallel to each other. Okay, and we can actually see that with the same thing, F to E and F prime to E prime. So again, it's kind of important to kind of understand how things are kind of related back and forth. Okay. So again, let's get some more practice on plotting points and kind of using our definitions of transformations to help with that. All right, and see if you also notice like the slope of the lines coming up when we translate them, if they end up being parallel. Okay, so we're going to do part A here. All right, so on your graph, it says we're going to plot the points A, B, C. Okay, and then we're going to apply this function to it. So we're going to walk through that point. So let's first plot. So A is 3, 3. So that's up there. B is 1, 1. So let me actually put, this is A, and then this is B. And then C is 6, 1. So C is 6, 1. All right, so I'm going to connect those points together. And then it says apply the function. So basically it says I'm going to take my x and I'm going to make it negative. So what this means is that A prime is going to look like this, negative 3, negative 3. So whatever negative, I just put a negative in front of it. 3 also became negative, so I have my new point. So I am going to be at negative 3, negative 3. So this will become my A prime. For my B prime, so again, I'm going to apply my negatives. So negative 1, negative 1. So negative 1 is probably somewhere right about there. B prime. And then my C prime will be negative 6, negative 1. So negative 6, negative 1 is C prime. So I'm going to go ahead, I'm going to connect all these together. I'm going to go ahead and actually, I'm going to move my A prime out of here. So I'm just going to write it down below. Okay. What do you notice? What single transformation do you think we can get from our triangle ABC to go to A prime, B prime, and C prime? So a single transformation. So do you think it's singly transformations or translations? Do you think it's really reflections? Or do we think it's a rotation? So take a moment, think about that. All right. So for this first one, this is actually a rotation. So hopefully you thought of a rotation. Now, were you specific about the rotation? Did you say a rotation of 180 degrees? Fantastic, right? If you said that, did you pick a point of where you think it was actually rotating from? And that point was 0, 0. This was the point of rotation. Okay, so be super proud if you just said rotation. Be super proud if you said rotation of 180 degrees. And again, if you went all the way and found the point of rotation at 0, 0, kudos to you. Okay, so again, it's about being specific. All right, let's try another one. Let's try C. So I'm going to get a new picture up. So C, it says use the function to translate this again. So I'm going to redraw 3, 3, and then 1, 1, and then 6, 1. Okay. And boop, boop, boop. And then I'm going to apply this new. Now notice what's happening with this one. Okay. So, so this time I need to take my original X value. So this is for my A prime. And I'm going to subtract 6. And then my original Y value, and it says I'm going to subtract 3. So that means my new point should be negative 3, comma 0. That's all we're doing. So it's basically kind of plugging in, simplifying an expression. So we'll solve it for B. So this will become 1 minus 6, and again, 1 minus 3. So this will give me negative 5, negative 2, and we'll do the same thing for C prime. This will be 6 minus 6, and then 1 minus 3. So this will give me 0 minus 2. I'm going to change my color, plot my points. So negative 3, 0. And that will be my A prime. B prime, negative 5, negative 2. So B prime. And then 0, negative 2. So this becomes my C prime. All right. And again, let's ask ourselves, we named the coordinates. Oh, it said to name the coordinates, I guess, a different letter, A double prime, B double prime. So let's do it. Since it's technically the same picture, that makes sense why they wanted us to be double prime. Okay. And then describe the transformations or the sequence of transformations. So looking at your graph, which was original in red, and then going to the new graph in purple, how did we get there? What is the transformations? All right, so hopefully what you're saying is that this is a translation. And how did you do it? You went down 3 and you went to the left 6, right? So if you go down 3, 1, 2, 3, and then over 6, right, we get to that B double prime. And notice that these numbers, 3 down, right, down follows the y-axis. Notice it's in the y position, okay? Notice that the 6 is going left and right, which is along your x-axis, which now is right here. Okay, so again, it's little things that I want you guys to start kind of paying attention to. All right, let's try one more. So let's try D. So D is a completely new graph. So it says on a new set of axes, plot and connect these points together. Okay, so here's our original. This is a quadrilateral, so notice that the triangle has gone away. So 3, 7 is up here. So it looks like that's my W. And then 3, 4 is my X. 9, 1 is my Y. And 5, 6, looks like it's right about there, is my Z. So I connect, 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 and then connect, something like that. Okay, so then what it says is how we're going to translate it. Okay, so my W prime, my X is going to turn into a negative X. So 3 is going to turn into negative 3. But notice that my Y stays exactly the same. So it'll stay as 7. My X prime is going to be negative 3, and my Y is going to stay the same. My Y coordinate. My Y prime was 9, so it's going to change to a negative 9. And then my Y stays exactly the same. And then my Z prime started with a 5, so now it's going to be a negative 5 and a positive 6. So notice that negative 3, 7 were right here. Negative 3, 4 were right here. Negative 9, 1 were over here. And negative 5 and 6 were right here. So again, connect our points together. And what do you think? What transformation can we map, right, to get one to the other? And hopefully in your head you said reflection. Now, we want to try to be as specific as possible. We want to say reflection across which axes? The y-axis. Because notice that this is 3 units away and this is also 3 units away. So this guy right here is my line of reflection. So again, we're just kind of defining our more rigid transformations and kind of understanding more how they work.